Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Irma Vep by Math Pesto. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through, fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or 9-cell region. A vampire cell appears once in every row, column, and box, which preys upon X of the up to 8 surrounding cells, where X is the digit in the vampire cell. A prey cell's value is 0, and a vampire cell's value is the sum of the digits in the prey cells it consumes plus its own digits. Vampires cannot consume each other, and multiple vampires cannot consume the same prey. Values in a cage sum to the given total. Digits cannot repeat in a cage, but values may. Okay, so let's try to figure out how that works. We have a vampire cell which appears once in every row. So there's a one vampire cell in every row, every column, every 9-cell region or box. And it preys upon the up to 8 remaining digits in that surrounds it. So basically, if this were, say, an 8, that would prey on all 8 digits that surround it. So these would be essentially preyed upon, and therefore they would have a value of 0. So all of these values of these cells would be 0. The vampire cell's value is the sum of all the digits in the prey cells it consumes plus its own. So this could be, I don't know, any combination. Say it's like we had like 8, 4, 3, 7, another 8, 6, 4, and 1. The sum of this digit is the sum of all the digits that surround it, and all the digits that it preys on. So since in this case it's 8 because it preys on all 8 cages, all 8 cells that surround it. And it would be including the sum of itself. So that's an example of how vampire cells work with preys. If, for example, you had, so this would be the value of this, the value of the blue cells here would all be 0 in this case, and the value of the vampire cell would be 24. 32, 42, 49, because it's the sum of all the digits that are preyed upon and its own digit. So a vampire cell can never have a 9 in it because it can't prey upon 9 cells. If we had, say, I don't know, this was, say, a 5, it preys upon 5 cells here, and it could choose which 5 it does prey on, right? So it could choose like, hey, it's not going to be preyed upon here, this is fine, and not going to be preyed upon here, and then not preyed upon here. So then this value would essentially, the blue cells would be value 0. The green cells would be the value of the digit in its cage, which would be 4 and 8, respectively. And the value of the vampire cell would be 5 plus the digits it preys upon, which is 8, 1, 6, 7, and 3. So that would be 15, 21 plus 9, which would be 30. So the value of the vampire cell in this case would be 30. And those are examples of how vampire cells work. And the values in the cages are essentially the values of each cell. And again, the value of the cells dependent upon the vampire cells. If there are no, if the cell is not preyed upon or is not a vampire cell, it's basically the value of the digit. If it is preyed upon, the value is 0. And if it's a vampire cell, it's the value of all the sum of all the digits that it preys upon, and added that with the actual digit in the vampire cell. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. Let's see. The sums here, this is less than 18. This is less than 15. Less than 31 doesn't help because these will naturally be less than 31. This is less than 8. This is also less than 8. This is less than 11, less than 15. So the ones that are helpful are the less than 18. So this will be helpful. And the less than 15. The greater than 44 should be helpful because that's 7 digits. Yep. So this should be helpful also. The greater than 25 will be helpful because that's 3 digits which are greater than 25. 2 digits greater than 20 will be helpful. Less than 8. Both of these combined is helpful, but I don't know if that's helpful in itself. We have less than 15, greater than 39. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So this should add up to 45 if there's no changes. Okay, so these are the helpful cages because we know, first of all, we know one of these 3 cage cells is, so greater than 45, one of these 8 cells is a vampire. Actually, the 20, one of these cells is a vampire because it has to be greater than 20, right? And the only way you get more than 20 for 2 digits, so these are very, very helpful, right? The only way you get more than 2 digits, 2 digits adding up to greater than 17, which is 8 and 9, is if one is a vampire cell. So one of these 2 is a vampire cell, which means none of these can be vampire cells. We're going to mark them as... So prey ones we're going to mark as blue. The other ones... So prey ones we mark as blue. Red is for vampire, and then unaffected is going to be green. So gray, we're going to say, is not a vampire cell. So that means this cell... So these 2 cells cannot be vampire cells. So this cell must be a vampire cell here, right? So that means the rest of this row and column cannot be vampire, and box cannot be vampire cells. So these are, one of these 2 is a vampire cell, which means none of these can be vampire cells. So one of these 3 is a vampire cell. One of these 4 has to be a vampire cell, right? You can't have 7 unique digits add up to greater than 44. You can have 7 add up to 42 at most. But with vampire cells, obviously that changes. So one of these 4 is a vampire cell, which means none of these are vampire cells. So the interesting... Okay, so none of these can be vampire cells because you can't only have 1 vampire cell in each row and column. Oh, that's interesting. Huh. This is greater than 39. But this can only prey on... It can prey on its cells from its own cage or cells from this 39 cage. But we know this 39 cage has to be greater than 39. So the preyed upon cells are basically going to be one of these cells here, right? So it can prey on at most... Okay, so this... How much value can this lose? None of these cells are vampire cells. So it can lose at most 2 cells worth of information. Because if it loses 3 cells of information where they all zero out, you have the digits 1 through 9 here, right? Because there's 1, 2, 3, 4, 5, 6, 7, 8, 9. This must add up to 45 at most. If you subtract out 3 digits, you would have to subtract out 1, 2, and 3 at least, which would make this 39. So this is only subtracting out 2 digits here. So this will only prey on two digits at most in these cells. And it could prey on its own cells here. Which I think it has to, right? To get to greater than 25, you gain 5 here. So say it doesn't prey upon its own cells. That would make this a 2 then, because it preys on 2 cells. You have 2 plus 8 plus 9 plus 5 at most that you gain from the preyed upon cells. So that would be 2 plus 5, which is 7, plus 8 and 9. That only gives you 24. This then has to be a 4. So it preys upon 4 cells. 2 of the cells have to be its own cells, which must be 8 and 9, right? So you have 4 plus 8 and 9, which is 21. And then you have 2 other cells which are preyed upon, which have to be 1, 2, or it has to be, adds up to at most 5. Because you can only lose 5 at most for this cage here. So 2 out of these cells are preyed upon. And they must add up to 5, right? So then we have 4 plus 8 and 9, which is 21, plus 5 is 26, which is greater than 25. So these are only preyed upon by these cells here, right? That means these cells cannot be preyed upon because you can't lose any of them. Same with this. This cannot be preyed upon because you can't lose that. And 2 out of these digits are preyed upon. Where is the 4 in this cage? It can only be here. So this is 4. It could be preyed upon because it could be preyed upon with 4 and 1 here. So this digit cannot be preyed upon by these 2 digits. This can only prey upon 3 digits at most, and this can only prey upon 3 digits at most. What happens if it preys upon 2 digits? Is that possible? Maybe. So if it preys upon 2 digits, it cannot be prey upon 1 digit. We know that for certain, because if you have 1 with 7, that adds up to 8, right? You could have 2 digits it preys upon. 2 and 7 add up to 9, and then the preyed upon digits would have to be 5 and 6? No, it's greater than 20. So that's a limitation there too. You have to have 3 and 7 here. That gives you 10. Or 3 and 6, or 3 and 7, or 3 and 5. If you have 2 with any digit, right, it sums up all that value. But the most that value could be is 5, 6, and 7, which is 18. 18 plus 2 would be 20. So this must be some common... These 2 digits must be preyed upon. Because... must be preyed upon. Because this can never be preyed upon twice. And it's part of the... It's either part of this prey, of this vampire, or it's not prey at all. Because you can't lose more than 5 in value from this cage. And these can't be summoned. These can't be preyed upon. This can't be preyed upon. Only 2 out of these can be preyed upon. period, because if you prey upon another one, you would lose the greater than 39 value. So this has to be some combination of 3, 5, 6, and 7 to have this work. So these two are preyed upon. This has to be a 1-2 pair here. That's the only digits remaining there. 4 has to be one of these digits here. 3 cannot be here, obviously, because, again, you can only prey upon 3 digits at most. So one of these is preyed upon, and the other one is fine. In these cells, you cannot have an 8, right? Oh, these are preyed upon, so this is 0 in value. This cell, so this is 0 in value here. This has to be 2 at most, which means the value of these cells have to be at least 40. Okay, so what are the remaining digits in column 7? They are 1, 2, 3, 5, 6, 7. And there are no repeat digits in cages, but values can repeat. These two digits must match these two digits, period. And they cannot be preyed upon. This could potentially prey upon multiple digits here. This... If this were the vampire cell, let's assume that was a vampire cell. What is the value this could be at most? It would be the sum of all of these and itself, right? So the sum of this cage would be these 3 values. This would be the sum of these 4 at most. And this would be 1, 2, and 1, 2 at least. So this is 42 here. And with a 2, that would add up to only 44. So this cannot be the vampire cell. What about this cell? If this were the vampire cell, it can't prey upon this because, again, the rest of this cage cannot be preyed upon except for by this 4 vampire cell. So it only prey upon that. And that's great. That's never going to be... The sum of these digits will never be greater than 40. It has to be 43 at least for prey, right? So this wouldn't work either. So this is not a vampire cell. What about this? Maybe? This would be the sum of these 4 digits, or these 5, really. So these 5 digits, plus possibly 1, 2, and 3. Well, what are the possibilities? You could have 9, 8, and 9, that it's the sum of. This could be 5, 6, 7, possibly, with a 4. So what is the sum of this? 4, 5, 6, 7, plus these 2, which is... So one of these 2 is a vampire cell, and this can't be. None of these can be because we have 1 per row and column and box. You could prey upon this. This is 18 plus 4 plus 2 at least, or at most. So 4, 5, 6, 7 is 22, plus 2 is 24, plus 17 is 41, plus 9. So any of these 2 can be essentially a preyed upon cell. So these 2 can be, none of these could be. Then This digit has to be one of these 3 digits here, because it cannot repeat in the same cage. These could be prey cells. These cannot be 1 or 2. So the remaining digits in row 7 are 3 through 9. Let's just make possibilities 3 through 9. 4 obviously cannot be here. 3 cannot be here. This is 1, 2, 5, 6, 7, 8, 9. Interesting. So one of these 3 is a vampire cell. None of these can be preyed upon because there's no vampire cell next to it. So these are all fine. Therefore, they cannot be 8 or greater. Ah. So this can't be 8 or greater because by itself they would be not less than 8. And none of them are preyed upon because there's no vampire cell next to that is neighboring them. So, where are the 8 and 9 in row 9? It has to be here. So these cannot be 8 or 9 here. These cannot be 8 or 9 here because we have 8 or 9 in one of these columns. This must be 1, 2, 3, 5, 6, or 7 here. So these are 1, 2, 3, 5, 6, 7 because these two match these two cells. Because the rest of the cells are 4 or are already in the box. So Interesting. What are the sum of all these numbers? It has to be 7 plus 7 7 plus 7 plus 10. And this, okay, so one of these has to be a vampire. I guess this could be... Okay. These are not sucked upon. These are not preyed upon. So neither of these could be 7. So it has to be either 1, 6 here, 2, 5. It could be 1, 6, 2, 5, or 1, 5, or 1, 2. These can be preyed upon. Okay, so what are the sums of these values then? We have 7 plus 7 plus 10 at most. That's 24. Right? We know there could be a vampire here. We know there could be a vampire here. Actually, we know there is a vampire here. They could be a vampire here, which could suck values from these digits, right? This value could be sucked by a vampire in these areas, right? So, assuming there's no vampire here, the only vampire that would suck anything is from here. So then the value of this would have to be greater than 45 at least. But this is less than 8, so it's 7 at most, 7 at most, 10 at most, 14 at most. So that, I guess we could have a vampire here too. Well, okay, we know there's no vampires here, so there has to be a vampire, obviously, in one of these 5. Vampires cannot suck other vampires. So, this is what is the values of these are 7 at most, 7 at most, which is 14, plus 10, which is 24, plus 14, which is 38. And we have obviously more than 38 in value. So if there is no vampire, well, I guess this could suck potentially out here. This would only suck that one. It cannot suck anything else from this set. And that if it only sucks that one, this would still leave a value of 45 here. So this can never be the vampire. So one of these 4 is the vampire. If it sucked both of these... If it was here and it sucked both of these, the problem would be that this still adds up. These values are not affected because this can't be the vampire. The vampire would suck whatever these are, but then this would add up to 7 plus 7 plus 10, which is 24. So this cannot be the vampire either. Okay, so we've highlighted the ones that we know. So this can't be vampire either. So the vampire has to be one of these 3 cells, which means the rest of the box cannot be a vampire. I think what it is that this is a vampire and this is a vampire, would be my guess. So this would suck the value from these 2 cells, and this would suck the value from these 2 cells. Obviously, if this is a vampire here, then you could only suck 1 cell from the other one, right? So if this was a vampire, this would gain the value of any cells it sucks. So that's not a net. That's a net 0 in that case. So if this were a vampire, only... I guess you could not have a vampire here then. So this could only suck there, or this could only suck 1. And that would remove only 1 value from all of this. Which would mean it's 36 at least, right? In value. So again, this can never be 1, 2 here. 1 of 1 or 2 is here, definitely. This could be a value of 0. Right, so if, say we had a vampire here, I think this is probably going to prove unavailable. If this is a vampire, say we had a vampire here, this could suck, this could take the prey from this one, so this would be removed. The problem is this is 36 at least, right? So you can remove 9, that would make this 27 in value for these cells. And that's already too big for 24. So this is not valid to be the case. So what if this was the other vampire? It could suck from both of these. But again, this would not be preyed upon. So the sum of these digits are essentially the sum of these digits because none of them are removed. Because then these would all be preyed upon by at best this one, which would then sum up to it, and that would be 24. So this cannot be essentially a vampire. So then two of these have to be essentially be preyed upon, right? Two of these have to be preyed upon. The other one is a vampire. So even if we just have two of these, so say this was the vampire here. If this is the vampire, you could have a vampire here. This would obviously not be a vampire. This would prey upon, this could prey upon these two. But this would, the sum of these digits would still be essentially these digits without these two, which is 8 and 9 at most. So that's 45 minus 17, which is 28, and that's still value greater than this, so this cannot be the vampire. Therefore, this has to be the vampire, which means this is not the vampire. This is less than 8. This must be preyed upon. These two must be preyed upon. You can prey upon all four of these, potentially. So this is not, this is a vampire here. Has to be less than 15, though. So including itself, okay, this is not preyed upon, unfortunately. These could be preyed upon, this cannot be. So this has to be some combination of, these are not preyed upon, these are not preyed upon. So this has to be 1, 2, 5, and 6, some combination, right? Because you can't, you could have 3, you could have a 3 here too. But 1 out of 1 or 2 has to be here, right? So, these two digits must be preyed upon. Because 1 out of these has to be 1 or 2. 1 out of these has to be 1 or 2. Right? This, if this is not 1 or 2, it has to be 3 and 5 at minimum, which is greater than 8. Or sorry, it's 8 or greater. And if this is not 1 or 2, this has to have 5 or 6. So the rest of the cells in the box cannot be 1 or 2. It's 3, 5, 6, 7, 8, and 9. Let's see. the sum of these values. So this has to be preyed upon by... One of these is 1, 6. The other one has to be 2, 3, or 2, 5, or 1, 3 here, right? So either way, if this... Okay, so either this is 1, 6, which makes this 2, 3, or 2, 5. This could be 1, 5 with 2, 3. So we're not guaranteed about 3, 5, or 6 here. Can this ever not be preyed up? This has to be preyed upon, I think. Yeah, because this is 3 with 1 and 5 at best. It cannot be 1, 2. If this is 1, 2, this becomes 3, 5 at least, and that's definitely not greater than 8. So, this has to be preyed upon. Same with this, I think. This could be, if this is 3, again, you have 1, 2. If this is not preyed upon, this is 3 or 4 with 1 or 2. It cannot be 1, 3, 4, because that's already 8. And that would leave this as 5, 6, which is not allowed. So this is preyed upon also. This can only be preyed upon by that cell. These two cells. So the value, okay, this cannot be 8 and 9 here. The most value this can be that you lose, it would be 7 or 9. So that's 16. 45 minus 16 is 29. Plus... this could be preyed upon by this cell. How many cells can this prey upon? You can't have 4, I don't think, right? If this is prior to prey upon 4, it would prey upon this. I guess it could be 3, 4, 3, 1, 2. I guess 1 and 1 technically. Okay, what? Obviously, it can't be 9 in this preyed upon cell. It can't be 8. That's too many. What is the highest amount you could this vampire cell could prey upon? Can it prey upon 5 even? So it could prey upon its own. It could be prey upon... Can this prey upon both of these? Is kind of the question, right? If it tried to prey upon both of this... Well, one of these could be 2, 3. You have some combination of these adding up to 14. So it cannot be 3 and 5. It can't be 3 and 6. 3 and 7 is the minimum here. So if it tried preying upon both of these cells, this is that minimum 3 and 7. This would not be 3 or 7. It would have to be at minimum 4. So it's 3, 4, and 7 is the minimum. And then it would have to prey upon one other cell. 3, 4, and 7 already adds up to 15. So it cannot prey upon this. So this is not prey here. This preys upon here. Can it be 5 that it preys upon? It could be 1, 3, and then 1, 2, 3. And that's the minimum for 5 that it preys. So 1, 2, 3 adds up to 6. 5 with that adds up to 11. And then 1, 3 adds up. So no. This is specifically 3 or 4 then that it preys upon. If this is not preyed upon here, we know this, then the sum of these 6 digits, it could work maybe. This would have to be 3 and 7. That does seem to work. So if this is less than 10, obviously it cannot be 4. I guess it could be 4 and 6 here, though, too. But if this is 4 and 6, the problem is these digits cannot add up, right? So if this is not a... if this is not prey, which means the value is not 0, these 2 digits can never have 8 or 9 with it, because 1 and 2 cannot be in that cage, right? So this would have to be digits from 3 through 7. These would then have 7 digits, which are 3 through 7, which would mean this has to be specifically 3 and 7. This is 4 then, if that's the case. So let's look at what that is. This is 3 and 7. This has to be an 8 or a 9 here, and this is an 8 or a 9 here. This has to be 4. With this 4 preying upon this prey cell. So this would be 8 at least. So this is 4 and this is 8. This would be 12, and then it preys upon 3 other cells, which is at minimum 1 plus 1 plus 2. So it's 12 plus 1, which is 13, plus 1 and 2, which is 16, which is not less than 15. So this one then also has to be prey here. This is also prey. And it could potentially be prey of this, but unlikely. Say this is prey and this is 3. This is then 4 and 5. This is at least a 5 then. Right, so if it preys on 3, if this is prey, if it preys with this, if this one preys on this, these two, it has to be 3 here, which means it preys on 4 and 5. This is 5. Or it could be 4 here, which preys on 3 and 5. Or 3 and 5, and then this could be 3 at minimum. That's 4, 3 plus 3, 5 is already 16. So these two must be preyed upon by one of these 2 cells here. This is 0 in value. These are 0 in value. This value is 0. So that's fine. How many digits are this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh. And the value is less than 18. Okay. That means we need to pull at least four cells or 5 cells? 5 cells in value. No, 4 cells in value. Okay. Can this ever be 9 that's pulled in value from here? I think the answer is no. If you have 3, you have 9 plus 3 plus, I guess it could be 1 and 1. So technically, the answer is yes. But, oh, it still includes that value, right? The 3 was assuming this is one of the values pulled, right? So the value of this, so you can have 7, 4, 1, 1. That's fine. 1, 2, I guess. These are not prey. If this was a 9, it's prey. It's prey of this vampire. So this would be 12 at minimum, or actually 4 and 3 at minimum for this value. So that would be 4 and 3 is 7 plus 9 is 16. So this cannot be 9. This cannot be 8 either. Because at best, this vampire pulls from essentially this one, this value, right? So it will contain that value. So this is 7 at least. If you have, it could be 3 and 5 here, but that would be higher. The only way this is 7, and this could be prey of this vampire, if this is 4 and 3. But the problem is it would pull from that one. It would have to pull somewhere else. So this cannot be 7 then. Excuse me. What we have now here in this box is a 1 through 6 sextuplet, which eliminates 1 through 6 in the rest of the box. Therefore, this must be a 7, 8, 9 triplet, which eliminates 7, 8, and 9 in the rest of row 7, because we have an 8, 9 and a 7, 8, 9 triplet, which means this cannot be 7. This is a 3, 5, 6 triplet, which eliminates 3, 5, and 6 from the rest of the row. So this is 4. This is 7, 8, or 9, but it cannot be 7 because one of these two digits must be a 7. This 4 pulls... Can this be the vampire? Obviously, this one doesn't pull from either of these. If this is the vampire, it pulls from both of these. So it's at least 2. It could be 7 and 8. So either of these could be vampires. But if this were the vampire, it has to either pull from this. So if this is 2 and this is 7, 8, this would be 1 at minimum. So that would be 1 plus 2, 7, 8, which is already 18. So this cannot be the vampire, which forces this to be the vampire. This is the vampire. It pulls from both of these. It either pulls... Okay, so say this was 3, and it pulled from here also, right? If this is 3, and this is the vampire, and it pulls from here, this would be 3, 7, 8 at minimum, plus whatever value would that be, which would be 1. So this could not work, right? 3 plus 7 and 8 is 18, plus 1 is 19, and it can't be less than 19 then. Because this is at best 0, right? This is at best 0, if that's the case. So this has to be 2. It must pull only these two, so 7 and 8. It cannot pull any of these, so these are not prey. Therefore, this has a value of 17. This must be 1, and this must be prey to add up to less than 19. So this is 18 at best. This is 1 and 2. This has to be a 9. This cannot be 1, 2 here, which makes this a 5, 6. So it has to be with 1 or 2 here. This can't be 1. This can't be 2. These could be preyed upon by this cell. So we don't know about anything about this. This is preyed upon by one of these two. Unlikely it's this one, but it's possible. One of these is 3. This cannot have 3, 5, and 6 in the rest of box 8. Okay. This pulls from 4 digits. It could pull from 2 of these and 1 more of these. Say it pulled from here. So it does not pull from this one. This one because that would be too big. This would be 3 if it pulled from that. So at minimum. So you have at minimum 3 and 5 here. That would be 8 plus 4 plus 3, which is already 15. So this one cannot pull from here. This one has to pull then from here and then these 3. So it must pull from these 3 here. This could be, so this cannot be 6. Can it ever be 5? You could have 1, 2, and 5. No. Right? If you have 1, 2, and 5, the problem is that 1, 2, and 5 already adds up to 8. I guess you could have a 4 here. That could be 4. But this can never be 5 here. If this is 5 or 6, this is 1 and 2, 1 and 2. It pulls 1, 2, 5 at least. So that would add up to 8. 8 plus 4 is 12, plus 3 at minimum is 15. So this can never be 5 or 6. This is a 3, which means this can't be 3. This is a 5, 6 pair, which means 3 has to be one of these digits here. Therefore, to prey upon something, you have to prey upon 4 and 1 to make sure you get 39. Because this 4 can't prey upon the 3. So this 4 has to prey upon the 4 here, and then one of these is 1. So these are not, okay, these cannot be preyed upon because the vampire does not choose them. So this has to be 1 in one of these 3 cells, so this can't be 1. This can't be 1 here. It can't be 7, obviously, to be preyed upon, so this must be 2, and this must be 1. This is 1, 2, 3, 4. This can't be 5 or 6 because that would be greater than 15. So this has to be 3, which means this can't be 3. This can't be 2. The 2 must be with... Okay, so 2 cannot be here. This has to be a 2, 3 here. So this is 2, this is 3. This can't be 1, 2, or 3 here. This can't be 1 or 2 here. 1 is one of these. So, okay, let's mark the preys. So that's easy. Center This preys upon here, this preys upon here, this preys upon here. This preys upon here, this preys upon here and here. This also preys upon these 3. That adds up to less than 15. This adds up to less than 19. These are just 2 straight digits, which are always going to be less than 18. This must be a combination of 1, 6, and 2, 5, no matter what, to add up to 7. So this can't be 5 here. One of these is preyed upon by the 4. We don't know which. This is a 1. So the remaining digits minimum have to be what? 2, 3, 4, 5, 6? What are the remaining digits in column 4? They are 4 through 9. This is 3, 4, 5, 6, 7, 8 in column 2. In column 1, sorry, column 3, the rest are 1, 2, 5, 6, 7, 8, 9. But these cannot be 1 or 2. These can't be 1. In this cage, there are no repeats, so 1 cannot be here. 1 cannot be here. Where is the 2? 2 can't be here. 2 can't be here. 2 has to be in one of these cells, which means this can never be 2. This is a vampire, so none of these can be vampires here. These could be vampired by this cell. In fact, one of these at least has to be vampired. And it's not vampired by this 2. So one of these 2 cells must... I guess one of these 3 cells must be a vampire. Right? Because by themselves alone, 5, 6, and 7 already add up to 18. And this is less than 18 in value. So neither of these can be... In fact, actually, what's the minimum here? If you only have... Okay, so if you have... Oh, this can only vampire that. So that would be 4 digits, which doesn't work. This can only vampire these 2. So that would be 3 digits already. So one of these 3 is a vampire. This cannot be a vampire here. If this is a vampire, how many would that eat? Would that prey upon? So this could be 8 and 9 technically. This would have to be at minimum 2, 5, and 6. What is that? 2, 5, and 6 is 13. So this by itself would be 13. Okay, this can never be preyed upon because it's not next to a vampire. These could be. This could be too. So technically this still could be a vampire because it could take 2, 5, and 6. This could be 8, 9. This could be a vampire sucking out, preying on these. Oh, wait. Well, no, this could be 7, 8 here. Okay, so 2 has to be one of these 3 cells. We know that for certain. 3 and 4 also have to be here, actually. Because where is the 3 or 4 in this cage? Can't be any of these cells, can't be here. And we know there's 9 distinct cells. So 3 and 4 have to be here, which means this cannot be 3 or 4. Interesting. This is not preyed upon. It's less than 15. Can it have less than... These 3 digits must be the same as these 3 here, right? They otherwise see all of these. They see that cell. Therefore, these 3 must be the same as these 3. 1 cannot be here. 1 cannot be here. This must be a 1 then. This is a 1, which means this can't be 1, which means this is 2. None of these can be 2 then. Where is the 2 in this cage? It has to be here. So this is 2. This is not 1. I don't know why. This is 2, which forces this to be 5. This becomes a 1-6 pair, adding up to 7. This is a 2, so none of these can be 2. So this becomes a 3-4 pair. Because this is 5, 6, 7, 8, 9 here. This has to be 5, 6, 7, or 8, but no 5 here, no 5 here. Only 3 of these can be prayed out. This is 4 through 9, 4 through 9 here, 4 through 9 here. No 6. So this could be 3, 4, 5, 7, 8, 9 here. This is 5 through 9 here, 5 through 9 here. So this is at minimum 5, 6, and 5, 6, right? If this is the prey, sorry, if this is the vampire, that means these 3 count at least. And that's 9. 9 plus 5 and 6 is 20, which is greater than 18. So this can never be the vampire. Oh, this has to be vampired by something. So it's prey. So this is the vampire. It can only vampire 5 at most, and it has to be 5 at minimum. So this is 5, which means 5 cannot be here. 5 cannot be here either. 5 can't be here. So this is not vampired out. Or this is not vampire or prey. Sorry, it's not it's not vampire or prey. This 5 means all of these are prey. So these are all prey. If this is vampire, the problem with that is that these have to be essentially part of this cage, or yeah, they have to be part of this cage then, if that's the case. So it cannot be if this is vampired, these will always be part of the cage, and we have 1, 4, 5, 6 at minimum, which is greater than 15, which is, sorry, 15 or greater. So this can never be the vampire, therefore one of these 2 is a vampire. None of these could be vampire. One of these 3 is a vampire here. So this vampire preys on 1, 2, 3, 4, 5. This is a value of 0. These must have 3 cells that are vampired out. It cannot have 2. If it's only 2, the problem is that it would be at minimum 5, 6, and 7, which is 18. So it must have 3 vampired out. We're not sure which ones. How about here? This must have 2 vampired out at least. It could have 3. Okay. Okay, what are the remaining digits in column 6? There are 1, 5, 6, 7, 8, 9. These are 0. Oh, this can't be 1 because of the 1 in the box. The remaining digits here are 4 through 9. So 1 cannot be here either. 5 cannot be here. 5 cannot be here. This is a vampire here, so none of these can be vampires. This is not consecutive with a vampire, so it must be... Right. One of these is... this is not prey or vampire. This can't be 6 because of the 6 in the column. The 1, 6 pair. Hmm. What else do we have? We know 1 and 2 have to be in these 3 cells here. Ah, that's interesting. So, if we try to have this be essentially the vampire cell, this can never... One of these has to be 1 or 2. Right? So it either includes 1 and 2 here, so these are both the same. Or this cannot be an 8-9 pair here, essentially. because we know 1 and 2 cannot be in rows 4 and 5. Sorry, 5 and 6. So they have to remain in box 6. They have to remain in row 4. Therefore, what's the most this value can be with this? It could be 9. 5, 6, 7. 9, 5, 6, 7, 8, 9, I guess, and then 1 or 2 twice. So 5, 6, 7, 8, 9 is the most. So that's 35 plus 9 plus 1 and 2 twice. That actually does work, so that's fine also. Ooh. Yeah, so that's fine. This can't be 2 because of the 2 in the row. Huh. Oh. These cannot be prey. Actually, none of these can be prey either. So these are the values that they have, but that's not saying very much. Because they're not involved with the cages, so it doesn't really matter what their values are. This can't be 5 here. So either of these two could be the vampire. Either of these two could be the vampire. Any of these 4 could be vampire. Any of these 2 could be vampire. One thing is, okay, this must take... So this is 35 here. This vampire takes 35 minus 17 value at least, which is 18. Therefore, the value of these two must be 4 and 5. Right? Because it takes 18 in value. That means that leaves only 9 more in value left. Even if it vampires itself, the problem is that it cannot vampire a value that would jump it past 10. And we have a 1, 2, 3 in that box. So that only leaves 4 and 5 possible in this box. So the 4 is the vampire here. It vampires 5, but it cannot vampire anything else. So this cannot be 4, 5. This can't be 5. These are all regular values because none of them are vampired. This has to be 4, 5 vampired. So it cannot vampire this one. So these two have to be prey, right? and it has to be 5, 6, 7 that is prey. So this could be 5, 6, 7, or this is 5, 6, 7. So this is not 6 or 7. One of these two is the prey, and the other one is the 8 or 9. That's fine. Therefore, either all three of these are prey. What does that mean? In box 2, that means we have 2, 3, and 4 left. Because we have a 1, 5, 6, 7, 8, and 9. Sextuplet. So this has to be 1 or 5. Right? Because 2, 3, this is 6, 7, 8, 9. It cannot have a 1, 2, 3, 4, 5. This cannot be 6 because the 5, 6 pair is here. Therefore, whereas the 5 in column 6, it has to be one of these two cells, which means this can't be 5. This is 6, this is 5, which eliminates 6 here. 1 cannot be here, so this is not being vampired. It's regular one. So the vampire is preying on one of these two. We're not sure which. This is regular. Can this... I guess it could prey on 2. Oh, this can't be 2. But this could prey on 2. One of these digits is a 6. Because this can never be 6 because of a 5, 6 pair. So one of these digits is a 6, which means this can never be 6. We have a 7, 8, 9 triplet in box 1, which eliminates 7, 8, 9 in the rest of the box. Therefore, this can't be 7, 8, 9 here. This is a 6, which means this can't be 6, this can't be 6, and none of these can be 6. Whereas the 6 remaining in column 2, it has to be here. So this is 6. This 6 has to be part of a prey. So this is prey here, which means this is the vampire to be able to prey on these 3 digits. This is not prey or vampire. This is 8 or 9, which forces this to be a 5, 7 pair. That eliminates 5 and 7 from the rest of the box, so this can't be 7 here. We have an 8, 9, 8, 9 pair. This preys on these 3 and its partner in the cage. And so this is prey. This has to be 4 that it's preying on. So this is 5, this is 7, this is 5. That eliminates 7 here. 6 cannot be here either. The only remaining digit here is 7 or 8. So this digit must be the same as this because there's no repeats in the cage. So this is 7 or 8 here. 9 has to be one of these two, which doesn't really tell us much. We have a 3, 4, 3, 4 pair in row 2, which eliminates 3 and 4 in the rest of the row. This can't be 3. This has to be 1, 5, 6, 7, 8, 9. This vampire means this cannot be vampire. So that leaves the vampire as here. This can't be 5 or 7. This could vampire 3, or could vampire 6. In fact, it actually has. Well, we know it has to vampire these three. So if a well, does it? 5 digits plus 9. So 5 digits uniquely is 35. So if you have 5 digits plus 9, but you can have these 2 digits. So you could have 6 unique digits. That gives you at least. Can this ever be 3 is kind of the question, right? Oh, this can't be 4 here. This can't be 5 or 6. What do we have left? We have 1, 2, 3, 7, 8, 9 as possibilities in row 4. Can this ever be 3 is kind of the question, right? If you have 3, it would pull. You would have at minimum. You could pull 1, 2, 3 here. That would be 9. And then these would be 1, 2, 3, 4, 5, 6, 7 unique digits. And they would have to include 1, 2, and 3 uniquely, right? Because 3 would be here. Only one out of these two can be 1 or 2. The other 1 or 2 would be here. And you can't. One of these would have to be 1 or 2, and it would have to be unique from this one. This one because it's in the same cage. These two because they're in the same column. This can't be 1 or 2. So this would have to be 3, 4, 6, 8, 9. It's possibilities. So this would be 3 plus a 1, 2 pair. The most for the other 4 cells would be 6, 7, 8, 9. And so it could be. It could actually still be 3 here. So if this were 3, it pulls, it vampires these 3 cells. You'd have 1, 2, 3, which is 6, plus 6, 7, 8, 9. 6 plus 30 is 36, plus 9 is 45, which is greater than 44. 6 obviously works because it pulls everything here then. And that would be fine. This is less than 31. That's not really restrictive there. What else do we have here? This is greater than 18. But there's no guarantee that this is not the vampire, right? So. This digit sees all of these digits here. So this cannot be ever 7 or 8 or 9. right, sees all the 6, 7, 8, and 9, which are unique in this cage. So this can't be 6, 7, 8, and 9. This is 5, which means 5 cannot be here. 5 cannot be here. This digit is the same as one of these two. This can't be 9. Because again, it must match one of these two. So this is 5, which means 5 cannot be here. 5 has to be one of these. Oops. One of these 3 digits. These digits here in row 1 are 2, 3, 4, 6, 7, 8, and 9. Obviously, if this is not the vampire, this is less than 31. If this is the vampire, there aren't that many restrictions, though. Less than 31 is still pretty high. Okay, what is the sum of these, actually? The sum of these is 31 without being prey. So 31 minus 14 at most is 17. So the vampire, whichever one it is, will pull 17, must pull 17 from these cells. But that's, I mean, that's perfectly valid. It could even pull 4, right? What's the minimum here? 4, 2, and 7, right? So 4, 2, and 7 is 13. And then it pulls 17 at least from here. So 17 plus 13 is 30. So that's potentially valid. So this is still up in the air. Obviously, again, if this is vampire, if this is vampire, it could still be 4, 2, and 7 even, and that's still valid. And it could vampire itself here. That would be fine. Obviously, this could also not be the vampire, which would force that to be vampire. Then this vampire is greater than 18 would work fine. 5 cannot be here. Okay, that's fine. So 5 has to be one of these 2 digits here. 5 is one of these 2 digits here, which means 5 cannot appear in anywhere else. Actually, we have a 5, 6, 7 pair, which eliminates 5, 6, and 7 in the rest of this cage, which means this can't be 6, this is a 3. This can't be 5, 6, or 7. This can't be 5, 6, or 7. These can't be 3 anymore. This can't be 3. This can't be 3. Where is the 3 in column 1? It has to be here. So this is 3. This 5 means this can't be 5 here. Where is the 5 in column 7? It has to be here. So this is 5, which means this cannot be 5 here. That's interesting. We have a 1, 2, 1, 2 pair here. This is 3. So we have 1, 2, and 3 in value. This must pull from these 3. If it pulls from anywhere else, it's too small, right? With 1, 2, 3, 9, and 9. Right, we knew that, okay, yeah, it's basically, this is at minimum for these 7 digits. 1, 2, 3, sorry, maximum. Has to be, these two have to be essentially unique because they're in the same cage. So it's 1, 2, and 3. And then we have 6, 7, 8, and 9 in this. That leaves us 36, which gives us 9 here. So this is 9, which means this can't be 9. This has to be a 7, 8 pair. We have a 7, 8 pair in box 8, which eliminates 7, and 8 from the rest of the box. So this can't be 7 or 8. This is 1. This can't be 1, 7, or 8, so this is 9. The 1 is preyed upon. The 9 is not. So this preys upon this preys upon these 3. So this is preyed upon. Oops, preyed upon. And these are preyed upon. Cannot be 1 or 2 here. This can't be 9 either. This can't be, this has to be 1 or 2 because it's the only other possibility for that cage. Sorry, for that cell. This again must add up to 6, 7, 8, 9, so 4 can never be here. 4 is one of these 2 digits here. We cannot have 6, 7, 8, 9 in the rest of the box because of the 6, 7, 8, 9 quadruplet. Therefore, this is 4 and this must be 5. Which means this cannot be 5, therefore this is a 5 here. This can't be 2 or 4 because of the 1, 2 pair in the column. And this can't be 1. So this is 3, 6, 7, 8, 9 as possibilities. And it can't be 6 because of the 6 in the row. This 4 eliminates 4 here. Where's the 4 in column 1? It has to be here. So this is 4. This can't be 3 here, and this can't be 3 here. One of these digits is a 9, and one of these digits is an 8 here. So that eliminates 8 and 9 in the rest of the column. This can't be 8 or 9. This can't be 8 or 9. Okay, whatever this cell is, I'm gonna make it, I don't know, pink and yellow. Whatever this cell is, this cell is opposite, so this is pink. This cell can never be here, so it must be here. So this is pink also. Yellow. Okay, this is a 7-8 pair. Well, that eliminates 7 and 8 from the rest of the row. So this can't be 8. This is 9. This is the 8, therefore. This 1 eliminates 1 here, so it's 6 and 1. This 6 eliminates 6 here, so this is 7, which means this can't be 7 here. 7 cannot appear here either. This must be the yellow 7 or 8, which means the pink one is here. The yellow one has to be one of these 3. That's not really telling us much. Pink must be one of these 2. Yellow, pretty broad. Pink and yellow are here. Hmm. Huh. Okay. This doesn't tell us anything. This again cannot have 8 or 9. So it could be 1, 2, 3, 4, no 5, 6, or 7 here. Hmm. This 7 means this can't be 7, so this is 6, which means this can't be 6. This can't be 6. Where's the 6 in row 5? It has to be here. This can't be 6. That means 7 has to be one of these two. That means 7 cannot be any of these three. We have an 8, 9, 8, 9 pair, which eliminates 8 and 9 in the rest of the column. So this can't be 8 or 9. This is 7, which makes that 8, which makes this 7. That's interesting. That means this cannot be 4 as the vampire adding up to this. But this, we don't even know if this is still the vampire. We don't have any information about this. What else do we have? Okay. Still doesn't tell us very much. One of these two digits is a 7. So that eliminates 7 in the rest of row 1. This can't be 7, this is a 2, which means this can't be 2, this can't be 2. Where's a 2 in column 5? It has to be here. This can't be 2 anymore, so that's 1, which makes that a 2. This 1 eliminates 1 here, so this is 2, this is 1. This can't be 1 or 2, so this is 7, which means this can't be 7 here, this can't be 7 here. This can't be 7 because of the 7 being one of these two cells. So where is the 7 here? It's one of these two digits here. I'm not sure which. This is 7. This can't be 2 here. 1 is one of these two. Okay. What does that tell us? I'm not really sure. We just know if this is a vampire, it cannot be 4. Because 4, 2, and 8, it has to prey on at least 2 of these digits, which must add up to 17. So 17 plus 2 and 8 is 27, plus 4 is 31. So that would not work there. But this doesn't have to be the vampire. This could be the vampire, and then one of these is the vampire, and that works perfectly fine. So that's why it's like kind of, ugh. These cannot be preyed upon. Oops. This cannot be preyed upon because we need all the values to get greater than 44. This is fine. This is fine. Let's do orange, and we don't have another color. Dark, I guess. So we'll make this orange. I guess we'll make this dark, which makes this orange and this dark. That makes this dark, and orange has to be one of these two. So orange is one of these two. Dark is here. Doesn't really tell us much. Dark can't be here, and dark can't be here. That doesn't tell us anything because one of these is dark. So we have to do the vampire thing then last. If this is 1, it has to be a vampire. If it's not 1, it could be not a vampire, right? So everything else I think checks out, right? This 3 vampires off 5, 6, and 7. So that's 18 plus 3 is 21, which is greater than 20. This 4 vampires off 9, 8, 4, and 1. So 4 plus 1, 4 is 9. Plus 9 is 18. Plus 8 is 26, which is greater than 25. These 2, 3, 5, 6, 7, 8, and 9 keeps its value, and 1 and 4 do not, so those are 0. 2, 3, 5 is 10, 6 and 9 is 15. That's 25, plus 7, 8, which is another 15, that's 40, which is greater than 39. This 2 and 5 keep its value, and those are the only ones, so it's 7, which is less than 8. 1 and 6 keeps its value, so that's less than 8, which is 7. 9 is less than 11. 4 and 8 and 9, whatever they are going to be less than 18. We have 2 plus 7 and 8, which is 17, plus 1, which is 18, which is less than 19. This is 0, obviously. So these are all 0. This is 8 and 9, adding up to 17, which is less than 18. This vampire is off 6, 5, 7, which is 18, plus... Wait. Yeah, no, that's fine. Yeah. 6, 5, and 7. Yeah, 5 and 5, which is 10. 4 and 6, which is 10, plus 7, which is 27, which is less than 28. So that cage works. We haven't done that cage. This cage, the 5 and 7 are 0 in value. The 3 vampires off the 9, 7, and the other 8 are 9. So this is 1, 2, 3, 6, which is 12. Plus 7, 8, 9, which is 24. 12 plus 24 is 36. Plus 9 is 45, which is greater than 44. So we just have to figure out this vampire and this vampire here. Obviously, if the vampire is in any of the cage, it's almost certainly going to be greater than 18. This case is the vampire can... If this is the vampire of 3, it could vampire the 2 and that would be fine. And it would still be less than 31. Right? You'd have 2, 3, and then you vampire 2 of these. But it doesn't even have to be a vampire. If it's not a vampire here, this is a vampire, which would force one of these to be vampires, and those all actually work. Oh, that's interesting. If this is the vampire, that would force this to be 3, which would make that 6, and this would be 1, which would have to be the vampire. If this is not vampire, that means this is 3. Oh, how many vampires can you have here? Okay, if this were the vampire, it can only vampire out 3 at most. Therefore, this would be 3, this would be 6, this would be 3 in the vampire. So none of these can be vampires here. If this is vampire, it can vampire out 3 or 4. But if it did 3... Okay, so if this is vampire, it has to vampire out at least 3, because 1 can never be here and 2 can never be here. If it vampires out 3, that means it would vampire out these 3 at best. And these 2 would be the only ones that are in play for the caged value. And that would mean this is a max value of 17. So this can never be vampire if that's the case. If this is vampire, it could be 3. If this is vampire, it has to be 3 to vampire out. So it has a value of 3. Oh, but that's fine. 694 is fine. Because that's greater than 18. So that's fine. If this is the vampire, it can only vampire 5 at most, but it can't be 1, 2, 4, or 5, or 3. So this can never be vampire then. Okay, that's interesting. Okay. If this is a if this is vampire, it can only be 3 because it must vampire out at least 2 of these. So, okay, what happens if this is vampire? If this is vampire, this can't be vampire. This is vampire. This has to be a 3, I think, right? This is 3. So this vampire is 3 here. That would make this 6 and this 3. So this would be vampire. That's fine. This can't be 6 or 3 here. This would be an 8, 9 pair. This vampire is off these 3. It cannot have a 1 here. Well, it could be if that's 6. This 3 eliminates 3 here, so that's a 4. This is 3. That makes this 4. This makes that 3, which makes this 4. This has to be 1. This can't be 1 anymore. This is a 1. So this becomes 6. That seems fine. This would have to be 9, obviously. Okay. This can't be a vampire because it can only vampire out 5. at most. But it has to be 6 at least in value. This could be 1 in vampire, then these two it vampire something else. It seems fine. Oh, that's interesting. Okay. So if this is 3 in the vampire, that means this is 6. This 3 means this is 4, which makes that 3, which makes that 4, which makes that 3. That makes this 4. The only other place for 1 is here. If this is the vampire, that means this can't be the vampire, which means this is the vampire and is 3 preying on these 3, and that would force this to be 6, which forces this to be 1 either way. So this is 1 either way, which means this is 1. This cannot be 1. Obviously, this can't be 1. That's a 3-4 pair, which eliminates 3 or 4 in the same row. So this is 8 or 9. Hmm. 嗯。So either this is prey, which makes that 3, 4, 3, 4, or this is prey. Which could, it just doesn't prey on any of these. It could prey on any of these cells, and that would still be fine. I mean, it could be prey on this 1, 7, and 3, 8 work, right? So, 3, 6, and 9. Dark does, interesting, have to be here, right? So dark is one of these two cells here because it can't be any of these. This is a 1 because of how we showed what this could be. Hmm. This is not pink, so the pink has to be here. So we know pink is here, pink is here, pink is one of these two, which doesn't tell us much. Pink is one of those two, which also doesn't tell us much. Pink is one of these two, which doesn't tell us much. Yeah, it's not helpful. I guess we're just gonna have to check both of these out, right? If we have all the vampire cells. Okay. Okay, so assume this is vampire and this is vampire. Again, this cannot be 4. The 3 can vampire its own region, so this would be vampired. 3, 2, and 8 is 13 plus 17. So pull vampires 2 out of these 3. We don't know which. This would be 4. This would be 3. This would be 3 because it vampires 2 digits. This would be 6. This would be 3. So this would be 4. This would be 6. That's fine. This is 4. This 3 vampires all of this. So this would be 9. This would be 8. This makes that 9. This would be 8. This would be 7. So this would be 9 here. This would be 7. Yeah, this seems fine. This would be 6. This would be 8. This all looks kosher. This would be 9, 8, 9, 8. So 9, 8, 7, 8. That's fine. So this is fine if we go that way. If we make this the vampire, this is obviously not the vampire. This is the vampire. It pulls these 2. It has to pull these 2, definitely. Oh, that can't be. If it pulls these 2, this is at minimum 1, 7, and 8. And therefore, this would not add up to less than 15. Okay, so that's the reasoning why that can't be this cannot be the vampire, and this can't be the vampire. Because if it pulls these 2, these 0 out in value, but this is at minimum 1, 7, and 8, which is greater than 15. Which is 15 or greater, shall we say. So this cannot be the vampire. This has to be the vampire, which forces this not to be the vampire, which makes this a vampire. This can only vampire 3, so this is 3, which makes that 4, which makes that 3. This cannot be the vampire then anymore, so this is the vampire here. This is prey. These are all prey because they're preyed by the 3. These cannot be preyed. And this 3 has to prey on 2 of these to add up to... This must be preyed on. So this is preyed on. And this is preyed on because otherwise it would be too big. So this is 3, this is 1, which makes that 4, which makes this 6. This can't be 6. This 6 eliminates 6 here. Well, the 6 has to be the one that's not preyed on here. So this is not preyed on, this is not preyed on, so this is 7. Which means this can't be 7. This has to be preyed on here. So this vampire 3 preys on these 3. This vampire 3 preys on these 3. This vampire 3 preys on these 3. And we just fill out the rest with Sudoku. This must add up to 19 or greater. So this can only be 9 then, which makes that 8. This 9 eliminates 9 here, so this is 8, which makes that 9. The 3 here eliminates 3 here, so this is 4, 3. 8 eliminates 8 here, so this is 9 and 8, which makes this a 7. Therefore, this is 8, this is 7. This 8 eliminates 8 here, so this is 9, which makes this 8, which makes that 7 and 8. This 9 eliminates 9 here, so this is 8, and these are not preyed upon. These are fine, so this is a 9. And that's how you solve it. Wow, pretty... Those last parts were kind of hairy still. It's just you had to think it through, I guess. Pretty interesting logic. It flowed very well up until this point. I guess I just had to try things out. But it flowed very well otherwise. Yeah, I guess I was looking for a more elegant solution than this. Well, I guess I could have. Is basically this couldn't be 6, right? So to contain this... Yeah, it's just interesting. It was basically just saying that this had to be finding out from this cell had to be a prey cell. And once you got that, you knew that this could not be the vampire, which forces this to be the vampire. I guess that's the elegant way of looking at it. I just wasn't able to spot that from there. That was a little difficult to spot. But it flowed very well throughout. It was very well done. The logic here was very sound. Interesting stuff with the cages and no repetitions. Yeah, overall, a very nice puzzle. And yeah, I guess it would be very hard because that last part took me a while to figure that out. Sometimes you just gotta try things out because that makes things easier to see. Because it's kind of hard to spot this specifically, that this could have to be a prey. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.